Okay, so in the last video we finished up putting together the code for this rectangle class. The last thing that I kind of ended on was talking a little bit about the constructor method that we created and the fact that we created two different versions of it, as we can see right here. So I want to talk a little bit more about why it is that we are able to actually create essentially two methods, two versions of the rectangle class. So we've got, or the rectangle constructor method, that have the same name, and how it is that Java is able to recognize which one of these two that we want to use anytime we try to call that method in, say, this demo class over here. When I make a call to rectangle, we want to make sure that we are able to understand why or how Java is able to pick between those. Okay. So in order to best describe this, we're going to go ahead and close out this current set of programs. If you're doing this from a project, you're going to end up closing out that project and creating a new one. And this new one that we're going to end up creating is going to be for a bank account class. So let's take a quick look at a UML diagram for the bank account class that I have set up already. So coming over here, we've got our bank account. This bank account will have a single field, which is the balance. The data type for this balance is going to be a double, and we can see the balance, just like all of our other fields, is going to be private. In addition to that, we're also going to create a couple of different methods for this. And if you look through this list of methods I've got right here, you're going to notice that we have the same name for this. A couple of these methods used multiple times. So we have three different versions of our constructor. So we have bank account 3 times. We then have this deposit method. There are 2 different versions of that. So you see that twice. Withdraw, we've got 2 versions of that. And then set balance, we've got 2 versions of that. And finally, we have a single get balance method. So why is it that we're able to create multiple versions of each of these methods? So this is going to be a concept that's known as method overloading. Okay. So method overloading is what allows us to create multiple methods that all have the same name. The key distinction, how Java is able to recognize which one of these methods we want to use, is going to be based on what is known as the method's signature. So the method signature is going to consist of 2 things. This consists of the name and data type of parameters. Okay, we'll place that, I suppose, just underneath it right here. Okay, so the reason that the method signature is dependent on these 2 characteristics of our method, the name and the data type of the parameters, is because of what happens whenever we call a method. So if we look at this rectangle demo for a moment, we can see right here when we make a call to the constructor, the thing that we have to specify in that call to that method is the name of the method, and then this pair of parentheses where we specify the arguments or the list of parameters. So as long as we're making sure that we include these 2 things in our method call, since these are going to be required for it, this is how we can determine or distinguish which particular method it is that we're trying to call in the first place. So that's the reason why it is that the method signature is going to be dependent on the name and the data type of our parameters. So if we look at each one of these methods, say with this bank account constructor, we can see that we've got the same name for them, but the data type of the parameters is going to be different for each one of these, meaning that the method signature is different. So that's how we are able to distinguish which one of these 3 constructors we want to call, depending on the kind of parameters that we're passing in. This is also going to be true for our deposit method. One version takes a double, the other version takes a string. With our withdraw method, one takes a double, the other takes a string. And with our set balance, one takes a double and the other takes a string. So because of that, as long as we are specifying either a double or a string as the parameter for it, that's how we know which version of this method we're trying to call. Okay. So the next thing I want to go ahead and do, since we're looking at this UML class diagram, I want to go ahead and create the code for this. So I'm going to go ahead and close the files for this rectangle. I'm going to go ahead and make 2 new files. The first one I'm going to make is the bank account. So if you're creating this as a project in an IDE, you'll just go ahead and make a bank account project. I'm going to go ahead and make that bank account. And then whenever you get the sort of default code inside of that bank account Java file, part of your source code, you can basically just go ahead and delete either all of it, or at the very least just remove the main method from it, since this bank account class is not going to be the class that holds the main method. Instead, this is just going to hold all of the methods that we specified in this class diagram. Okay, so the first thing we need is the header. So we're going to have public class bank account. Then have the pair of curly braces to start the body of this class. The first thing I'm going to go ahead and do is make the field. So we specified that it was going to be private in order to achieve proper data hiding. We then have the data type for it, which was double, and then the name is going to be balance. We can also go ahead and initialize this to 0 right here. The next thing we're going to do is create each one of those 3 constructor methods. So again, we're going to use public, and then we do not have a return type, so we leave that off, and then we just put the name of the class to indicate that this is going to be a constructor method. The first one's going to be the noargs constructor, so we just have an empty pair of parentheses here. We then have the pair of curly braces to start the body of this constructor. And for the noargs constructor of this, what I want this to do is basically just keep the balance set to 0. Since we're already doing that right here, you could effectively just do nothing here. But in order to be a bit more explicit so that we know precisely what it is that what we intend for this method to do, I'm just going to go ahead and repeat this. Okay. For the next one, if we take a look at the class diagram, the next bank account is going to require a start balance variable, or a parameter. It's going to be of type double. So we'll go ahead and add that here. So we've got public bank account, and then we have our double start balance. And for this one, what I want to do is use the start balance as a way to initialize the value that I'm putting into my balance field. So we're going to do our balance, and we'll assign to it the start balance. Okay. The next one we're going to need is one that uses a string. So we're going to have another constructor. For this one, the parameter is going to be of type string. We call it str. And for this one, what I need to do is take that string. I'm going to use that to initialize my balance field, assuming that maybe the input that we're getting from the user is in the form of a string. Initially, we want to convert that to a double. So in order to do that, we're going to take our balance field, and this is going to be equal to, and then we're going to use the double class. We'll have our dot, and then we're going to use the parse double method and put the string into that. And then we can do this. Essentially, we're going to take that string and then parse from that a double that is inside of that string, and then put that into our balance field, or assign that to our balance field. All right. Now that we've got our 3 versions of our constructor, the next thing we're going to do is create our deposit method. So we have 2 of those. So for this, we're going to do public. Now we're going to get back to having to specify a return type. So we're going to make void, and then this is going to be deposit. And for this one, when we do this first deposit, we're putting in some amount for our bank account in the form of a double. So we're going to do double, and then the name that we went with was amount for this. So we're going to do double amount. And for this one, what we want to do is basically take the amount that we're specifying and add that to our balance. So one way we could write this is we could say balance is equal to balance plus our amount. So basically we're just saying whatever the current balance happens to be, add amount to that, and then store that or assign that back to balance. Alternatively, we could also just use a combined assignment operator to kind of shorthand this. So instead of doing this whole part right here, we can just say plus equals amount. So we'll just take whatever the current balance is, add the amount to that, and then store the entire thing back into balance. All right. The second version of our deposit method is going to take a string. So we're going to have our string. We again will just call this str. And for this one, it's basically the same as what we do for the first version of balance, where we get this amount. The one difference is that we also need to go ahead and parse from that string the double. So that also requires doing what we did in this third version of our constructor. So we're kind of just combining the functionality of these 2 together. we're going to have our balance. We'll use our combined assignment operator, and then we'll have that double class, the parse double method, and then our string. Okay. The next thing we're going to have is the two different versions of our withdraw method. This is very similar to the deposit method. The only difference now is that instead of depositing or adding an amount to our balance, we're going to withdraw or subtract some amount from our balance. So we're going to have public void withdraw. We're going to have our double amount for the first version of it. And for this one, the only difference is that we're going to subtract from the balance. So we're going to do minus equals using another combined assignment operator, and then the amount. And then this other version of withdraw looks pretty much identical to if we did, the deposit for a string, but we're just doing a subtraction. So we're going to do public void withdraw, specify our string, of our body. We're going to do balance minus equals double dot parse double with the string. Okay. And then the last three methods are going to be our setters and getters, or our mutators and accessors. So we're going to do first the setters. We're going to use two of these for basically two different versions of being able to set our amount, whether that's with a double or with a string, very similar to what we did for the deposit and the withdraw. So we're going to do public void set balance. We can pass in some double, we'll call it val. Alternatively, you could also call this something like new balance. And then we're going to take the balance and we're going to assign to that the val that gets passed in. We'll then have a second version of this, which will take a string, again calling this str. And for this one, we're going to take our balance and assign to that the parsed double that we get out of that string. And then finally, our last method is going to be our getter or our accessor. So for this one, we're going to do public. For this one, since we are going to return something from this, the data type for this will actually be whatever the data type of the field was. So the balance is of type double. So that's what the return type is going to be here. So we're going to do public double get balance. This particular method will not require any parameters, so we'll leave that pair of parentheses empty. And then the only thing we need to do here is just return the balance. Okay, so at this point, this will cover all of the methods that we want to create for our bank account class. So we've got all of our constructors, the two different versions of our deposit method, the two different versions of our withdraw method, two versions of our set balance method, and our get balance method. So the next thing I want to go ahead and do is create a second file, and in that second file, that's where I'm going to place the main method for this program. So we're going to go ahead and create a new file. Again, if you're doing this from an IDE, make sure that when you create this new file that you create it in the same package or the same folder directory as the bank account that we just created. So we want to make sure that these are both in the same location. I'll go ahead and save this. And for this one, I'll use a similar naming convention and call this bank account demo, much like what we did for the rectangle and rectangle demo pair. So we'll go ahead and create the header. So we'll have our public class bank account demo. We'll have the pair of curly braces for the body of our class. We'll then create the main method. So we'll have public static void main. Specify our one parameter for our main method, that string array of args, and then inside of here we're going to start adding some code to construct objects of the bank account class and then try to use some of the methods of it. So the first way that I'm going to approach this is by just explicitly or just kind of hard coding some values into this. So we're going to create our bank account. I'll call this something like just account. This is equal to a new bank account. And then inside of here, I want to, for this first part, we'll go ahead and just leave this pair of parentheses empty. So we'll just kind of initialize this account with a balance of 0, and then we'll go ahead and set that and then get it a little bit later. So the next thing I'll go ahead and do is just call the set method. So we're going to go ahead and set our balance. So let's say that we start off by setting this to maybe some amount based on maybe some kind of payment, like an initial deposit. That's where the set balance would come in. So we'll go ahead and put in something like, let's say $1,000 right now. Okay. And then the next thing we'll go ahead and do is use the get balance method. So we're going to do something like print statement. And for this one, I'm going to go ahead and make this a little bit more elaborate than what we did for the rectangle class by actually creating a statement to go along with the balance that we're going to be displaying. So we'll say something like the current balance is, we'll have a $ plus our account dot get balance. Go ahead and save that, and then we'll go ahead and compile this and run it just to see what it looks like right now. Just this little bit of code that we've added, and then we'll continue to add on to this as we go. So we'll come over here and compile. So we're going to compile both the bank account and the bank account demo. So we're going to compile that successfully. We'll then go ahead and run our bank account demo, since that has our main method inside of it. And right now we can see that we're getting the statement the current balance is $1,000 with our decimal point for our change being slightly off on the number of decimal places right now. So maybe one of the other things we'll go ahead and do is also fix this a little bit and add a little bit of formatting, string formatting to this. So if we want to go ahead and do that as well, we can go ahead and remove this print line. We'll replace this with a printf, and then instead of doing a concatenation here, we'll just go ahead and add a little format specifier here. So I'll have a placeholder for where the balance from the account should go, and we'll go ahead and format that to 2 decimal places. So we'll do a %.2f, and then right here, instead of this plus sign, we'll just have a comma specifying that the balance that we get from the account is going to be the one additional parameter that we want to replace this format specifier with. Okay. So go ahead and save that. We'll go ahead and run this again just to see that small change. And see, now we can actually get it to 2 decimal places. Okay. All right, so the next thing we're going to go ahead and do after we set the balance, we also want to be able to test out things like making a deposit or making a withdrawal. So we'll go ahead and do that as well. So we'll go ahead and grab this account again. And the next thing we're going to do is maybe make another deposit. So after our initial deposit with the set balance method, now we can start making additional deposits where we're actually adding an amount to whatever it is that we kind of initialized our balance to. So maybe we want to make an additional deposit of something like $500. So if we do that, we're going to add that to the $1,000 we have already. So we'll end up with $1,500, and then we'll go ahead and do a withdrawal. So we're going to do account.withdraw, and for this one, maybe we want to withdraw just a little bit of money, so maybe another $300. So we'll go ahead and save that. And so then by doing all of these, we'll end up with $1,200 for the balance. So we'll go ahead and compile this and run it and see a little bit from each one of these. And we can see in our print statement that we end up with the current balance is $1,200. Okay. All right, so the next thing I want to go ahead and do is modify the way in which we're getting these values. So right now I've just kind of hard-coded these values, meaning that I've explicitly stated what amounts I want to put into or take out of this balance in the code itself. But in practical terms, this isn't very useful or meaningful. So ideally, the way that you typically want an application like this to work is you'd rather allow the user to specify what amounts that they want to put into or take out of this account. So ideally, we want to go ahead and add in something like a scanner for this. So we're going to do something like import java.util.scanner. And then what we can go ahead and do is start adding in some additional print statements here to ask the user for some kind of input, say being able to set their balance and then deposit an amount and then withdraw an amount. So we can do something like do a system.out.print. And for these, I'll go ahead and do print instead of print line because of the fact that at the very end of this, the user is going to provide their input and then push the enter key. So because of that, it's going to move to the next line anyway. So we're going to leave off the print line there. So say something like, please enter the amount in the account. And then we'll have our $sign right there. And then right here, we're going to go ahead and say account.setBalance. And instead of putting the 1000 right here, we want to add in a call to a scanner object and one of the methods of it. So we'll go ahead and make that scanner object as well. So maybe above our bank account, we can have a scanner. Call this something like keyboard, fairly standard convention for a scanner related to keyboard input. We'll say this is equal to a new scanner. And we're reading from the standard input stream, so we're going to use system.in here. Okay. And so then right here, we'll go ahead and use that keyboard. And then we want to go ahead and call one of the methods for it. In this case, we're expecting a double related to the amount. So we're going to go ahead and say keyboard.nextDouble. Okay. And then we'll do something similar for each of these deposit and withdraw methods. So we're going to have system.out.print. Again, using print instead of print line because we expect them to push the enter key at the end. And for this one, we'll say please enter the amount to deposit, $sign. And right here, we'll have the same thing. Again, we need to use that keyboard, the scanner object that we made. And again, this is going to be a double, so we'll just use next double. And then finally right here, we'll say system.out.print. Please enter the amount to withdraw, $sign. And we'll have keyboard.nextDouble. Okay. So save it like that. We'll go ahead and run it and now see that we can do the same application but with the user being able to specify their own inputs each time that they run the application rather than it just being the exact same values every single time they run it. So we'll go ahead and recompile this. We'll go ahead and run our bank account demo, and now it's going to ask us to input the amount for the account, so the initial amount that goes into it. So again, we could say it's something around 1,000. Maybe to demonstrate that this is going to be different, we can start with something a little bit higher, something like 1,500. We'll then ask for an amount to deposit, so maybe we want to deposit another, I don't know, $400. And then an amount to withdraw. Maybe we want to go ahead and withdraw most of what's in there. So then we can just go ahead and withdraw a little over half of it, something like 1,000. And then at the very end, we can see the current balance is this $900. And if we double check the math on this, we got 1,500 plus 400 gives us 1,900 minus the 1,000 that we withdraw leaves us with $900 in the bank account. So you can see everything's matching up correctly. Okay, so far we've seen this application taking in some inputs for each one of these methods, our set balance, our deposit, and our withdraw, but currently the only thing we're specifying is a double for these. And if we look back over at our bank account, you know, we're only really using the first version of things like deposit, withdraw, and our set balance. And ideally what we want to be able to do is also test this with these other methods so we can see this idea of method overloading actually taking place. That is to say that, you know, in one context, this current version of the bank account demo, we're accessing the versions of these that use a double as the parameter, but maybe we want to write this in such a way that we can use the string instead. So one particular way that we could approach this is that instead of using a scanner, we could just go ahead and do this with dialog boxes. So we're going to go ahead and replace this import statement here so that we can go ahead and use dialog boxes instead. So the import we're going to use instead, we're going to do javix.swing.jOptionPane. So this will give us access to the jOptionPane class, and from that class we can go ahead and access things like our input and our message dialog boxes. So we're no longer going to need this scanner. And for each instance where we're providing a print statement, instead of providing these print statements asking for user input, instead what we're going to go ahead and do is just get some kind of input from the user. So that input is going to need to be in the form of a string, and what we're going to do is we're going to get the input and then store that into a variable so that then we can go ahead and use that variable in these methods. So we'll go ahead and do something like string input. This is initially going to be equal to just an empty string. And then right here we can go ahead and do our JOptionPane.show input dialog. And for the show input dialog, we just need to go ahead and specify that statement again. So we're just going to say, please enter the amount or the initial amount, enter the initial amount in the account. Okay. And then the result of this, when the user sees the little text field to input some amount, they'll push the OK button or hit enter, and then it's going to return that value. So we want to go ahead and have a variable here to store that returned value. So we're going to use this input string that we had and put that right there. Okay. And then right here, instead of doing keyboard index double, what we did for the scanner, we're just going to replace it with this input. And so the expectation here now is that this input is currently in the form of a string, but that's perfectly fine with the setBalance method because we have a version of setBalance that can take a string and then go ahead and parse that to a double for us. Okay, so we got that right there. And then for each of these two, we're going to go ahead and do the same thing. So I'm just going to go ahead and grab this line right here. I'm going to copy that and replace these with that. And then also go ahead and modify this. So we've got please enter the initial amount in the account. Then we're going to say please enter the amount to deposit. And then for this one, we'll say please enter the amount to withdraw. Okay. And in both of these cases, the value for input, we're just going to use that every time. We only really need to store it right here and then use it right here. And then we can just go ahead and overwrite that with the very next one. Place that there, and then place it right here as well. Okay. So the first time that we get something in input, the thing that's going to go into setBalance is just the initial amount that we're going to put into the account. The second time around is going to be the amount we want to deposit, and then this third time around is going to be the amount that we're withdrawing. And then right here at the end, instead of doing a printf statement, so we're going to change this as well to use dialog boxes. So we're going to do JOptionPane.show message dialog. The first parameter we need is going to be the value null when it comes to a message dialog, slight distinction from the input dialog. And then right here, I still want to be able to do this formatting, but since we're not using a printf anymore, we're going to need to use a different method. So I'm going to use the format method of the string class. So I'm going to do string.format. Put that right there. Let's go ahead and add some word wrap so I can still see everything. And so that's going to cover everything there. And we'll go ahead and put one last parenthesis right there. Okay. And then just to make sure that this is a little bit easier to follow, go ahead and move that to the next line. That way then it's a bit more readable. Okay, so we'll go ahead and compile this, take a look at it. Run that. Okay, so now we've got our input dialog box. It's asking us to enter the initial amount in the account. So maybe I'll go ahead and test it with the same amounts I used for the scanner. So I'll do 1,500 initially. We then need to enter an amount to deposit, so do something like 400, and then an amount to withdraw. Go ahead and take out another 1,000 again, and we can see at the very end with our message dialog, the current balance is $900. Go ahead and push OK on that, and that'll end that one. Okay, so at this point now we've gotten a chance to see the different ways that we can use this set of classes, this bank account and bank account demo. By taking advantage of method overloading, we can actually write the account demo in a couple of different ways and access these methods, set balance, deposit, and withdraw in various ways. Additionally, keep in mind that the constructor could also be used in a couple of different ways, say like this noargs constructor or the two different kinds of parameterized constructors that we provided. So there is some variance or some variety to the way we can use the constructor in addition to these three methods. Okay. So this is going to wrap up everything for method overloading. Going into the next video, we are going to expand on this particular program just a little bit more by also taking a look at the inclusion of some additional methods besides the main method in this bank account demo, and using those additional methods to manipulate these bank account objects in some way.